Swayam Prabha. Digital India. Educated India.
In this digital age, where softwares form the backbone of our daily lives, one has to demonstrate unparalleled expertise and creativity in crafting a solution that addresses contemporary challenges with ingenuity and precision. Today we have one such team with us. Let's meet Yuvraj and his team and know all about their work. Welcome guys, welcome to the show. So please tell us something about yourself first.
Hi, I'm Yuvraj, team leader of Monolith. So I was, apart from being the team leader, I was also responsible for machine learning model and data generation. And this is my team.
My name is Anubhav, and I and Yuvraj were simultaneously working on generating the data and then feeding it into our machine learning model. Carrying on to Aman.
Hello, my name is Aman Kumar. I'm a pre-final year engineering student, and my role in team was as a web developer. I implemented the whole UI and integrated with ML model.
Wonderful guys, it's very nice to have you here. So let us start with the problem part now. So what problem are you in after? What is that which you're trying to solve, and how is that going to help us? We'll talk about that later, but let's talk about the problem first in detail.
Okay, so the problem is very specific. So whenever there is a signal from satellite that is coming to Earth, be it a television signal or be it a mobile signal or anything. So whenever the data is coming from satellite, it gets the bit patterns get like if it is 0 1 0, then it becomes 1 0 or something like that due to the environmental things and stuff like that. So what happens is when we apply this FEC schemes into it. FEC is a is a technique basically which is used to encode the signals that are coming from satellites. So before modulation, if we apply FEC scheme to the signal, then we can kind of make it a bit more safer for the transmission. So our problem statement is basically to detect which FEC scheme was used to encode the signal. So we can detect it and we can decode it on the Earth.
So basically, scientific community should be looking forward to what the work that you've done. So let's get straight on to that, the kind of work that you've done. What is the solution that you came up with? What exactly did you make?
Okay, so as you can see in the presentation, we used MATLAB, Simulink simultaneously to generate the data. We generated a huge amount of binary data that was in BPSK, QPSK, and 4PSK modulation techniques, and then we put forwarded it through our 5 error correction schemes, as you can see in the next slide. We actually implemented 6, but in the presentation it says 5. That is BCH, TPC, Turbo, Hamming, Convolutional. So what are these error correction schemes do? As they safeguard your data. Say suppose that 2-bit data is converted to 5 bits, and then what happens is they find the Hamming length in Hamming code specifically. There are specific different algorithms that run in the background. One of them is also LDPC that we implemented that we have not mentioned it here. Okay, so what does it do? It safeguards your data, and then after you convert it back to the normal data, after you demodulate it, it safeguards your data and it ensures that the error that is faced should be the minimum. So what we did was, in this prototype, our machine learning model implemented bits and patterns. It recognized the bits and patterns using RNN to make the data more environmentally variable, because the data is not as smooth as you get it for. So we implemented it in SNR ratios. What is SNR? It is sound to noise ratio that is added when the signal is translated from one point to another. So we implemented it from 1 decibel to 10 decibels. And then for each of the different models, we implemented the machine learning code separately for each modulation schemes. After that, it shows us a bit pattern format. Like, what is bit pattern? After you translate it through a specific correction scheme, it shows some patterns that the machine is able to recognize after 1,000 approximations, after 1,000 epoch. Epoch is a technical term for the amounts of time you train the data on the specific format. This was a huge data arc. We took two laptops and then we implemented it in a very rigorous format. We worked 36 hours non-stop. Our laptops were running and our machine learning model was getting trained again and again, again and again. As we put more data into the model, it had to be retrained again.
Yeah, of course.
Yeah.
Okay, so can we have a look at some kind of a prototype or a model which can shows the working of it? Like how does it really happen?
Okay. So what we did was we implemented the machine learning model into a web app using Flask. Aman is going to tell you about it.
Okay, so basically we made our model with TensorFlow, and after that with Python we integrated it with Flask APIs. We integrated it with our pure HTML CSS web app. And now shall we show a demonstration?
Yeah, please.
So basically this was our landing page for our website, and when we get started, here's the files we can choose. And with the trained model, as we can see, it is giving our percentage at what's the maximum possibility of the file which we have chosen. In our demonstration, it is showing convolutional FAC scheme, which is the highest, which is the correct answer. That the file we have chosen was of convolutional FAC scheme. It says the probability and the graph of the solution.
Okay, so if I talk about the impact part of it, how do you think this will impact the scientific community or the researchers or anybody engaged in such spheres?
Okay. So actually what happens is after you modulate the data and then you demodulate it, there are some bit patterns that our machine learning code is able to specify, right? We think that researchers can study that bit pattern and for more, we can amplify the impact that we're doing it with this small model. We can find out more details about the bits and patterns that is still undiscovered. Our model is going to help them move forward into that part of the research.
Okay, that sounds very encouraging. It's really going to help them. So, what is the way forward now? Like you've reached till this particular point.
Yeah.
So, where do you want to take this from here?
Okay, so actually we are trying to implement more of the forward error correction schemes, and we're going to implement more modulation and demodulation techniques. So as soon as we get a demodulated signal, we are able to identify, oh, this was encoded using that FEC scheme, and hence we can find out the bit patterns, and we can modulate and we can find the original data more specific to the one that was originated from the point.
And we can also use different types of data. For now, we are using string or txt file. After that, we can use audio, video, or any other extension file with which we can train our model and get the accuracy.
So basically, we can expect more of inputs or more of functionality coming into your solution.
Yes, sir.
Okay, so can you tell us about the model architecture that you've used here and how it works?
Okay. So here is our deep learning model architecture, as you can see on this slides. At the first, we have our input layer, which goes through the convolutional layer. Moving on to the activation function, that is float32 that we have used here. We move it to the next convolutional layer. So what happens is these are artificial neural networks that are working simultaneously to find out bits and patterns from our data. As you can see, the input and output slides that are mentioned here, these are the bits and the parts of the slides that it is extracting to find the information. And then the extracted information is forwarded to the next layer, and the next layer, when it finds something meaningful, it forwards it to the next layer, and the chain goes on.
Okay, so this works for you, right?
Yes, sir.
Great. So what about functionalities or any other features which are helpful?
So it can be used in multiple places. So we have cybersecurity as well, where we can identify malicious attacks that are coming from another country. Suppose this is coming from another country which is a neighbor. So if it is coming, we can detect which FEC scheme was used to encode that signal, and then we can possibly decode that data. And because currently we have to know which FEC scheme was used to encode the data, then only we can decode it. But with the help of machine learning model which we have made, we can detect in the unknown demodulated signals as well. So it can help in the next generation communication as well. So we can build communication systems where we don't have to worry about the FEC encoding. So we can encode our data in any FEC scheme that fits into our data, and we can like send it over the satellite. And it can also improve the wireless communication as well, because then we have more flexibility of choosing FEC schemes. We don't have to tell the receiver that this was used for FEC, this FEC scheme was used for encoding and all.
Okay, great.
Actually, our machine learning model is gonna recover the signals that are from harsh environments. We're gonna train it for more SNR values. It's currently from 0 to 10. We're gonna increase this decibels, and so after even we get a ruptured signal file format, we're gonna decode it and we're gonna extract some meaningful information out of the signals. Also, this is gonna increase the spectrum efficiency. Actually, what happens is it's gonna optimize the bandwidth by enabling efficient error correction schemes even in noisy channels. So if there is a data leak, or if there is some bits and patterns of the file that are missing, our machine learning model will be able to enumerate it.
Okay, great. So I'm sure this is going to help quite a lot to all the researchers and science enthusiasts and scientific community as a whole.
Yes, sir.
Great, guys. It was good to have you here, and congratulations on your winning the SIH 2023 and coming up with this wonderful piece of solution. Thank you so much for your future.
Thank you for having us, sir.
Thank
Thank you.
We extend a heartfelt congratulations to the winning team of Smart India Hackathon 2023. May their success inspire future generations of innovators to push the boundaries of what is possible, contributing to the continued growth and prosperity of our nation. Goodbye.